All right, in number 61, we have two separate particles, and these are their position vectors. The question is, when will these particles collide? All right, so the x's are at the same place when t is 2, and the y's have the same value when t is 5.5 or t is 2. So when t is 2, these particles will be in the exact same place. All right, and then there's a part B in this question. Find the direction of motion of each particle at the time of collision. What's the direction of each particle at the time of collision? So what is the direction of particle 1 when t is equal to 2, and the direction of particle 2 when t is equal to 2? Okay, let's take care of this. All right, well, to know motion, we need to know the velocity vector, because the velocity vector tells us what direction it's heading in and how fast. So if we take the derivative of the horizontal component and vertical component, we get the velocity vector. Again, derivative of each component, we have the velocity vectors. Now we know the motion. We know the direction it's going in and the speed. So if we know the direction via this vector, we can find the direction that each particle is moving in when they collide at t equals 2. Well, this one should be easy. At 3/2, its direction is pi/4. Or 45 degrees. And for this one, we can just do the inverse tangent ratio. So the inverse tangent of the y-coordinate over the x-coordinate. There you go. Particle 1's motion is moving in the direction of the inverse tangent of -2. Particle 2's motion is in the direction of 45 degrees, counterclockwise of the positive x-axis. And that's it. We're done with number 61.